Hi guys, in this video we're going to solve radical equations. There are basically three steps for solving a radical equation. The first step is to isolate the radical. In other words, get the radical by itself, the square root, the cube root, the fourth root, whatever it is. The second step is to cancel the radical by squaring both sides or cubing both sides or raising it to the fourth root, fourth power, whatever it is, to cancel it out. And the third step is to solve the variable. Always make sure to check your answers at the end for extraneous solutions. All right, so we'll start this first problem by isolating our radical. I'm going to add the square root of x plus 1 to both sides. Add the square root of x plus 1. So on the left side, it cancels out. I'm left with x minus 5 equals the square root of x plus 1. Okay, step 1, done. Isolate the radical. Step 2, cancel the radical by squaring, cubing, whatever it takes. So since I have a square root, I'm going to need to square the square root. Squaring a square root cancels out square rooting. What I do to one side, I'll always do to the other side. I have a little trick for squaring a binomial. I call it square the left, meaning square the number on the left. So if I square the number on the left, I get x squared. Square the right. So negative 5 squared is positive 25. Multiply these two numbers together, which would give me negative 5x, and double it, which would make it negative 10x in the middle. I call that the McFadden shortcut. When I square the square root, I get x plus 1. All right, now the last part is to shift everything to one side so that I can factor. So I'll need to subtract x from both sides. And while I'm at it, I may as well subtract 1 in order to get 0 on the right side. So that will give me x squared minus 11x plus 24 equals 0. I'll factor. When I factor, I get x times x, and two numbers that multiply together to give me a positive 24, which means my signs are the same. I'm going to use negative 3 times negative 8 gives me a positive 24. When I check and I do my outside inside, I would end up with outside will give me negative 8x, inside negative 3x, and together they give me negative 11x. And once we know it's factored correctly, we set our factors equal to 0, and we would have x equals 3 and x equals 8. Remember, before we're completely finished, we'll go back to the original problem. We plug into the original problem and check our answers. So let's check 3 first. We plug in 3 for the x's. We have 3 minus the square root of 3 plus 1 minus 5 should equal 0. 3 minus the square root of 4 is 2, minus 5 equals 0. 3 minus 2 is 1. 1 minus 5 is negative 4. Negative 4 does not equal 0. Therefore, 3 is considered to be an extraneous solution. It doesn't work. We'd have to throw that one out. Now we'll check 8. Plugging 8 in, we have 8 minus the square root of 8 plus 1 minus 5 equals 0. 8 minus the square root of 9 is 3 minus 5 equals 0. 8 minus 3 is 5. 5 minus 5 is 0. 0 equals 0. That's true. So 8 is a solution. So we move on to the second problem where we have the fifth root of 5x minus 8 plus 16 equals 18. So we start by isolating our radical. We'll subtract 16 from both sides. We have the fifth root of 5x minus 8 equals 2. To cancel out the fifth root, I'll raise it to the fifth power. What I do to one side, I always do to the opposite side. And the left side will give me 5x minus 8. And the right side, 2 to the fifth, not 2 times 5, but 2 to the fifth power. 2 times 2 times 2 times 2 times 2 is 32. Now we add 8 to both sides. We get 5x equals 40. Divide by 5, and we get x equals 8. For the sake of time, I'm just going to tell you 8 does work, but you should plug it back in and check your answer. The third example, we have 4x plus 4 to the 2/3 power plus 10. We're going to start by subtracting 10 from both sides, and we have 4x plus 4 to the 2/3 power, which, by the way, is a radical. To the 2/3 power, the bottom number, the 3, is the root. So that is the cube root of 4x plus 4. The top number is an exponent, so it would be squared. So it's the cube root of 4x plus 4, all squared. But we're just going to leave it as a fractional value. And just know that fractional exponents mean that you do have a radical. 26 minus 10 is 16. So to cancel out to the 2/3 power, we're going to raise it to the reciprocal power, because a power to a power means that we multiply our powers. We would have 2/3 times 3/2 would give us 6/6, which is to the first power. So we would end up with 4x plus 4 to the first power. What we do to one side, we have to do to the other side. So we'll raise 16 to the 3/2 power as well. You could use a calculator, or remember what I said a moment ago about the bottom number is the root. So it's the square root of 16. And then whatever you get, the top number is the exponent, so we would cube it. So the square root of 16 is 4. 4 cubed is 64. So we get 64. Minus 4 from both sides, 4x equals 60. Divide by 4, and we get x equals 15. 15 does work when we plug it back in. Remember, you'll always plug your answers back in and check your answers. I'm going to save this problem for tomorrow as well as this one. And for the pre-AP students, I did this problem in class. We always start by isolating our radical, so I'm going to add 4 to both sides. And we have 5 times the cube root of the square root of 2x plus 1 equals 25. We'll divide by 5 on both sides. So we have the cube root of the square root of 2x plus 1 equals 5. To cancel out the cube rooting, we will cube both sides. So 5 cubed is 125. And like I said, cubing cancels out cube rooting. So we end up with the square root of 2x plus 1 equals 125. To cancel out square rooting, I'll square both sides. This is going to be a big number, but that's okay. A calculator, and we have 125 squared. I get 15,625. And on the left side, squaring cancels out square rooting, so we have 2x plus 1. We'll subtract 1, which gives us 2x equals 15,624. Divide by 2, and we get 7,812. We would check that answer into the original problem, and it does work. Have a great day, students.